All right, folks, I think we're going to go ahead and get started. Hi, everyone. How's everyone doing? Good? All right, end of the day, got some energy going, I like that. So my name's Gabe. I am the lead program manager for the cloud native compute team here in Azure. We're gonna talk today about fundamentals of Kubernetes on Microsoft Azure. Got a lot of great speakers here. We got myself, we got Alan, who heads up a lot of this work in the sort of Kubernetes and container space in our Azure CAT team, customer advisory team. We've also got Rasmus here from Maersk, who's gonna talk a little bit about how Maersk is using AKS and containers, containers to deliver containers, physical containers. Pretty cool use case. And we're also going to be joined by Janny, who is an author, analyst, and a real expert on the IoT space. He's going to show us some stuff in IoT. So I'm really excited to get through showing you a lot about what Kubernetes on Azure looks like today. So, to start, what I want to do is I want to provide a little bit of an introduction to just some general concepts for those of you who may be new to Kubernetes and containers. So, before we start, I'd love to see a show of hands. How many people are beginners? We'll go beginner, intermediate, advanced, right? Beginners. Okay, lots and lots of beginners. Okay, great. How about intermediate folks? Intermediate knowledge of Kubernetes. Okay, and advanced. Where are my advanced people at? Few hands, okay, I see them, okay. So, and by the way, how many people are using AKS, even just like dabbling with it today? Okay, great. After this, then that number is going to be a lot higher, I suspect. Okay, so the first thing I want to do is just talk about a little bit about the space that we're in, and containers, Kubernetes, a lot of excitement around this technology, a lot of customer interest, because this is solving real problems for real businesses. Gartner has this quote that I love, which is that by 2020, more than 50% of enterprises will run mission-critical, containerized, cloud-native applications in production. That's a pretty crazy stat. It's funny for me because I got my career started, working on containers very early on. I was one of the largest contributors to the Docker project back in 2013 when it first started. And everyone that I worked with on this technology, it was all early adopters. It was basically companies who didn't have anything to lose, wanted to take a bet on new technology because the potential value was really high. And what's happened is this has totally changed now. And what we now see is that large companies are actually leading adoption of container technology. It's gone from sort of the early phase to mainstream enterprise adoption rather quickly, I would say. And this is in part because companies like Microsoft and platforms like Azure have just made it so compelling and so simple to get going. Now, another thing that's changed is that when I started working in this space, there's containers and then there's container orchestration. Container orchestration is basically the art of juggling lots of different containers, container-to-container communication, service discovery, rolling updates, health checks, mounting volumes, things like that. A while ago, it was unclear sort of which container orchestration technology was going to win out in the eyes of the market. And what's happened is, over the last, 12 months or so, we've had a real big consolidation in at least open source container technology around Kubernetes as the leading orchestrator for the industry. You can now get Kubernetes services from all of the major cloud providers, not just Azure. And yes, our service is the best. But you can also get one from Amazon, Google, Microsoft, IBM, Alibaba, Oracle. Everyone is offering a version of this. So if you value portability, Kubernetes is going to be a very important technology as part of your overall tech portfolio. It's also extensible. There's lots of things you can do to wire into Kubernetes, custom schedulers, custom admission controllers, to sort of bend it to both the needs of your operations team as well as the needs of developers. And one of the critical aspects of it as well is that it provides self-healing. So while you may be using containers in another environment, what happens if the machines fail or if something in your workload fails a health check? With Kubernetes, it all sort of heals itself, and the system pushes itself very rapidly towards matching the desired state with making the current state match that desired state, which is a very important element. So to talk a little bit more about how that works, the step one with using Kubernetes, sort of just like the 101 here is, you will use a Kubernetes client, something like kubectl, to talk to a Kubernetes API server. And what you'll ask for is, I want 10 versions of this particular container image running, with these parameters, and I want it to be, checking on, for health on port 80, and I want it to mount this volume in because I need to store some files on this volume. And so, you'll ask basically for that desired state. That state will get replicated into a data store called etcd, which is a quorum-based data store. Now, this is sort of the expression of your intent as a user of how you want Kubernetes to work. From there, what will happen is that there's all these componentry, actually a set of microservices, not surprisingly, that are going to enforce that desired state. These are things like the API server, which will accept the request, the controller manager, which will sort of manage different components in the system, like replication controllers and deployments and services and things like that. And then the scheduler, which will basically assign the different Kubernetes pods to different nodes in the system. Now, that management componentry is actually very important, but where you scale out here is on the worker node side. And here's where you'll have worker nodes effectively running this thing that we call the kubelet, which is an agent that sort of heartbeats back to the API server and says, hey, I'm alive. I'm alive. You can schedule work on me. And the scheduler will say, OK, and it'll start placing workloads onto those nodes. Now, you also, on the worker nodes, have the kube proxy component. And what that does is it facilitates the ability of pods in Kubernetes to talk to other pods in Kubernetes. So pod-to-pod communication, which is very important for microservice environments. Lastly, you'll have worker nodes that are capable of taking direct requests from the public internet. So this is going to be through what we call ingress resources, where you say, hey, I want this set of services identified by these labels, app equals front end. I want that to be exposed at the internet at this host name or at this path. And magically, that route will get set up, and traffic will start flowing to all those pods, no matter where they are running in the system, thanks to the magic of the kube proxy component. Now, this all may sound complicated, and it is, right? Distributed systems are hard. They are complicated. But it turns out that this works extremely well at scale. And there are so many examples of companies that are using Kubernetes in production at very large scale. So how does this work on Azure, though? Well, on Azure, you're using the same flow. You're basically, as a user, you're expressing your desired state in an application workload definition. And then you're kicking that over to a Kubernetes API endpoint. And from there, you're interacting with these components on the master node. Now, this is what would happen in the case where you're not dealing with Azure. You're going to have to set all this stuff up yourself. You're going to have to manage upgrades for this. There's a lot of work involved in this. So what we've done is we've basically turned that control plane into a API as a service, right? You can now get, through AKS, you can get Kubernetes API as a service. We deal with not just the control plane, but we also will stand up the VMs for you. We will manage the entire environment for you. And all you have to deal with is, what version do you want to be running on? How many nodes do you want in aggregate in your cluster? You manage by node pools. But you're basically just a Kubernetes API consumer at that point. And that's actually, I think, really, really important because it allows you to focus on using Kubernetes and being effective with Kubernetes and containers rather than on how to operate it. Because there really is no added value for most of the folks in this audience on being better at operating Kubernetes. And it's going to be hard to beat Azure at that. So the next thing I wanted to do was just show how you can get started with this extremely easily. So let me cut over here to my machine. So what I want to show you is something called DevOps Project. How many people here are familiar with DevOps Project? A few of you? OK. So what DevOps Project does is it allows you to do two things at once. One, in this case, is it'll spin up and manage an AKS cluster for you, but also set up an application, a sample application, full-blown CI, application telemetry, and the like. So let me show you just how simple this is. Go hit New in the portal. Choose a DevOps project. I could pick a language. We'll pick, Node.js. We'll use the Express framework, happens to be my favorite. We'll use the Kubernetes service, which is the default. Now, I can actually choose to create a new DevOps project environment, or I can use an existing one. I actually have my own here that I've already set up. I can call this Ignite Demo. And I can choose what location I'm using. Now, there's also a whole bunch of other things I could change, modify here if I hit that change dialog. But if I go ahead and hit done, what this will do is this will just fire off the creation of not just a new AKS cluster, but it'll also create an application and deploy that application to the cluster using a Helm chart. So what this ends up looking like, I'm not going to wait for that to spin up. But if I jump down into one that I created earlier, you can see what this looks like at the end. What this looks like is, up here you have this concept of this the CI/CD pipeline. So, the source code living inside of Azure DevOps that is used to drive this particular application. Anytime changes are pushed to that source code, it will be reflected here inside of the Azure portal, which is really nice. You don't have to flip to a different portal. You can link direct to the repository, also see which Azure resources are involved in your cluster, which is really nice. And then you also get this really great application insights telemetry. This is cool because this comes as part, standard part of the sample app that we deploy. So you actually get, as part of, it's a click to my deployment there. You actually, as part of this, you get access to how many successful requests were made, how many failed requests occurred due to the way that this sample app is instrumented. So it's a really great way to get started. Take that sample app, start tweaking it, start modifying it, and you get to do all this inside the Azure portal, which is really terrific. All right, back to our slides here. So to wrap up here, I think it's really important to point out the things that you're getting from the Azure Kubernetes service versus what you'd have to do on your own, right? So if you are standing up Kubernetes at the IaaS layer on Azure or on VMs or on your own on-prem environment, there is a whole ton of stuff that you're going to have to do around standing up machines, around upgrades. The process around upgrading a Kubernetes cluster is extremely complicated. Alan will go into that in a bit more detail in a moment. Patching, scaling, monitoring, logging. All of that is now provided by Microsoft as part of this managed service. It's going to make your life as an operator or as a developer much, much easier. Now, when it comes to sort of the top of the stack, things like CI/CD, how you do your application authoring, what your inner loop looks like, how you actually build your container images, we have a lot of tooling to help, but you're still sort of on your own. And the point I want to make here is that Kubernetes is still relatively, low in terms of a application and developer primitive. There's a lot of API surface to Kubernetes, and so there is some work that you're going to have to do around how you write YAML files and construct this stuff. Yes, we make it easier, but if you're looking for sort of a more easy to use PaaS solution that just is sort of push button, there are other products in the Azure portfolio that are more mapped to those needs. Now, if you're looking for portability, for the ability to run containers on lots of different environments, including on-prem, if you want to go where the industry is going in terms of adopting open source technologies, you're going to want to take a deep look at Kubernetes. All right, great. So with that, I'd like to invite Alan up to talk a little bit more detail about AKS. Thanks, Alan.
Thanks. Was that for Gabe or me? No? Okay. Yes. All right. Thanks, guys. All right. So I'm going to talk about some of the AKS. Give you an overview of AKS, right? So AKS, managed Kubernetes, fills in a bunch of different spaces around simplifying, getting you to an enterprise containers as a service platform. I work a lot with a lot of large enterprises, and they're at the stage right now where you had a few business units that did actual Kubernetes deployments, some smaller Kubernetes deployments, had success, and now you want to take and scale this out across your enterprise. And you have a few decision points that you want to make. Do we do DIY? Do we just pull upstream Kubernetes? Do we get an opinionated platform? Or do we use the managed platform? And so when you think about the managed platform is all about simplifying your experience doing Kubernetes. So if you've done any Kubernetes, there's a term that we have that when you start out doing Kubernetes, you should all do. It's called Kubernetes the hard way. A bunch of VMs, you, coffee, drugs, whatever you need to keep going. It'll take you about 3 days to finally get a cluster up and going. You'll be in the community a lot, you'll meet a lot of different people. AKS is about simplifying that experience, allowing you to just work with your applications and think about how you want to deploy your applications from your developer and scaling them up, all right? So, Kubernetes momentum is off the charts. We've had 10x the growth of people moving into Kubernetes, on people deploying on Kubernetes in Azure, and then we have 5x the number of customers deploying to Kubernetes. And why is that? There's a lot of momentum around containers, and when people start to deploy containers and start to deploy microservices and they get out of the initial investigation using something like Swarm, where they start out with a small cluster, getting introduced to container orchestration concepts, and then moving large scale, we want to scale this out and do it broadly, Kubernetes is where a lot of people actually land. Okay? So a ton of momentum around Kubernetes. I don't need to explain that to you. You probably already know that. You probably heard it. There's a container euphoria. If you were on Sunday at the Container Fest, we walked through orchestration engines, Kubernetes, and showed you how to do deployment and use some of the various tools that you can use to deploy your application. So lots of momentum, lots of interest, and like I mentioned, the enterprises are now at the stage where they want to take and scale this out across their enterprise. They want to offer enterprise containers as a service, either leveraging Azure or leveraging an opinionated platform. Okay, so this says Kubernetes the old way. So when you think about creating a cluster, it should really say the hard way, or near next to impossible way, right? We've actually simplified the process of creating a cluster. So if you were actually going to deploy a cluster, you'd have a bunch of VMs. You need to decide what network overlay capability you want. If you wanted to have persistent storage, which storage technology you want to use, Gloucester, Chef, NFS, iSCSI, VMware vSAN. All these things are for you to decide. We've simplified that into a simple command. AZ, AKS, create cluster, name, finished. Specify the number of nodes that you want. Now you're up with a master API server, and you're up with a working cluster. In a simple set of commands. If you do that the hard way, take 2 days, 3 days, maybe you never get it running correctly. So we've simplified that. And that's the whole purpose of AKS in a managed instance, to simplify your experience of getting your cluster up and going so you can concentrate on your applications and doing application deployment. The same thing around upgrading a cluster. So the native Kubernetes way is you upgrade your master API server first, and then you start in on the worker nodes. So if you have 10 nodes, you have to individually drain the node, make sure that any open connections or any existing connections are satisfied. Then you cordon the node off, you fence it, no more new traffic. Then you upgrade all the system components on the VM, and you do that for every worker node you have. So a lot of people celebrate the fact that they have large clusters. When you have to do a manual upgrade of it, you don't really celebrate. It's a lot of manual work that goes on. We've simplified that into a AZ AKS upgrade command. So what are we doing? We're actually doing upgrading the master and then draining and cording the servers until we cascade, until we get through all of them. So upgrading your cluster for something like Kubernetes 110 to Kubernetes 111 is a simple command. All right, same thing on scaling, okay? So if there's 2 types of scaling in Kubernetes. You can scale your app, multiple replicas. That's easy to do. But when you need to actually add additional capacity, a node or a worker node to Kubernetes, now you need to provision a VM, install the components, and then join it to the cluster. That's a simple command, street-step command, AZ, AKS, scale. And now you can actually scale out the system. So when you think about the hard way, which you probably want to do the first time you start working with Kubernetes for learning, but when you want to scale out the system and build it out as an enterprise containers as a service offering, you want to use a managed instance that simplifies some of the process of maintaining and upgrading your cluster. Okay, so we look at the end-to-end experience, right? There's a few different components. So you start from the developer experience, the inner loop, if you will, from Azure Dev Spaces. Anybody heard of Azure Dev Spaces? No? Okay. What it is from the actual UI, VS Code and Visual Studio, we actually have a tie into AKS and Kubernetes. So a developer working in his IDE, building source, builds a container, and wants to do debugging of a container. So it gives you an F5 local debugging experience, but the kicker is it gives you an F5 remote debugging experience of containers running in Kubernetes remotely in Azure, directly from your Visual Studio IDE. Right? So the developer works in the tools that he normally uses, source tools, Visual Studio, and the IDE, and he's able to work with containers and work with Kubernetes instances, building things like a Helm chart, which is the de facto package manager for Kubernetes applications and deployments. Building a Helm chart, which Helm is source, and storing that in the source control system, and then actually either pushing code directly into a container registry, or building in a source control system things like Jenkins and Artifactory, or some of the big, Jenkins, Artifactory, and Ansible are the big ones that enterprises typically use today. Getting your image into your container registry, and then from your container registry, actually deploying in AKS, in your clusters, right? Front end, back end, different microservices that you're actually deploying. And this slide actually shows something that's really interesting from an enterprise perspective on something you actually have to decide. Where do I store my data for applications? That is one of the biggest things that developers ask. Because for your stateless components, those are kind of easy. Those are microservices, stateless. They don't take a dependency on any persistent storage or persistent data. But one of the best practices is to store data in data services, in cloud data services. That way, you keep your containers immutable. They go away, Your data is actually stored in a data service. Now, we know in one of the scenarios I'm going to talk about in lift and shift, that may not always be possible, but it's the best practice to store particularly data sets in a data service. That way it's fungible, you disconnect your containers away from your data. Okay? Because if you want one thing about the Kubernetes architecture, it's declarative, it's immutable, where containers just run your app, they go away, they come, they go, you know, the cattle and pet concept, if you will. And of course, using some of the Azure services around monitoring. This is another thing when enterprises start to deploy enterprise containers as a service that's kind of an afterthought, right? Operations and management and monitoring. I call it day 2. So day 1, you have your Kubernetes clusters up and running, you have your inner loop going with your developer tools, your container registry. Now you've deployed an app. You start to think about managing and monitoring it. You start thinking about liveness and readiness probes in Kubernetes, taking triggers. Everything's trigger and event-based in this architecture. Taking triggers and doing things like scaling, notifications, management, and logging. So Azure Monitor is a really good tool for pulling together everything all in one place. And I believe there's some sessions this week that talk about this experience using things like Azure Monitor, monitoring pods, monitoring clusters, looking at labels and tags, and being able to take action based on it. So now you have this end-to-end architecture, right? This is a simplified architecture, and it's now your job to take this simplified architecture and scale it throughout your enterprise. But it starts with this basic architecture of pods, the developer experience, CI/CD pipelines, and then monitoring. Okay, so security is not important to anybody here. I'll just glaze over this slide really fast, not talk about it. Yeah? Yeah. One thing in working with enterprises, work with developers, we have the project, we kind of have a general idea of the architecture, and then we go in for the security review. And most security folks in enterprises, while they might have a good handle on container security standards, now you put Kubernetes in the mix, and generally, you come out of that room with, I think we need to slow down our deployment. Because I don't know where all this stuff is being secured. There's more firewalls in this architecture than I'd care to admit. There's a firewall before the mobile client, there's an API gateway, another firewall after the API gateway, a firewall before the load balancer, a firewall after the load balancer, and a firewall, but if you have something like ExpressRoute, a firewall delineating your network bridge and ExpressRoute into Azure. There's firewalls and rules all over this place. And I just asked security people, this is good, so it looks like good security in depth. Who's managing these policies? And it's exactly what you hear in the room, crickets. Well, somebody owns it. Who owns it? Well, there's 10 different policies we just created. NSGs, ASGs, whitelisting. We're super secure, but nobody knows who's going to actually manage all these different policies, right? So some of the things that we do, particularly in AKS, to help you along this process is RBAC. And what is the practical way that enterprises use RBAC today? They use it to secure namespaces. Because if you're going to do a multi-tenant deployment in your enterprise where you're going to have multiple applications, and you want to be able to give developers the ability to have some visibility over their Kubernetes resources, you're going to do that in a namespace. Namespace is going to give you an isolated construct. But you also want to secure that namespace. So you want to associate an Active Directory group to that namespace that represents that business unit's developers, and by default now, they're able to have a lockdown namespace that only that developer group or team can access. That's the practical way that people use RBAC and namespaces, particularly as people start to think about enterprise containers as a service and scale this out for locking that down. That includes things like Helm and Tiller, locking that down to a namespace and using AAD groups to ensure that only people that have signed in Active Directory can actually use those resources. Secrets. Okay, secrets management in Kubernetes. A lot of debate, hot topic. A lot of enterprises think, whoa, secrets management. Kubernetes does auto rotation of all my secrets. Kubernetes secrets and application secrets. And I'm like, wow, what distro Kubernetes is that? That's an amazing distro. No, you have to think about how you want to handle your secrets. And one of the things that we do in AKS is integrate AKS secrets and your application secrets with Key Vault. So Key Vault can be used to store Kubernetes secrets, but also can be used to store your container secrets. Because one of the big things that always comes up is, how do I get secrets into my container? And the number one answer, the no answer, the non-cloud answer is storing certificates in containers. Because now what did you do? You just made cattle a pet. Now you have to protect it. Now you have to rotate the certificate in the container. Now you have state stored in the container, and that's definitely an anti-practice, right? But at container runtime, application runtime, your application can request keys from Key Vault. So one thing that you want to think about, external services and integrating services around AKS and Kubernetes and Azure services is really what makes the full left-to-right experience go. So creating clusters, simplifying the creation and upgrading of clusters, but then integrating those additional services from the CI/CD pipeline, dev spaces, Azure DevOps, Key Vault, to ensure that now you can really create a left-to-right containers as a service offering. And of course, security and VNet access, the ability for you to be able to control, deploy into your own VNet and control using NSGs, rules, who can associate, who can talk to different systems using NSGs in Azure, all right? And last but not least, regulatory, heavily regulated environments around HIPAA, SOX, or PCI. Azure's AKS service has been certified to work with those different regulatory environments and compliancy standards. And that just inherits part of the Azure all-up compliance profile and standard. So scale with confidence. So the Kubernetes architecture allows you to scale your applications, right? So scale replica sets. But there's a bunch of other things you need to kind of think about when you scale out this enterprise containers as a service offering that you have. So of course, we have built-in auto scaling at the pod level. But you want to also think about, how do I integrate additional node capacity into my AKS or Kubernetes environment? And one of the enterprises I work with had the notion of 3 clusters: East, West, and Central. And using a distributed load balancer like Traffic Manager from Azure, they did it in a deterministic way, determine how traffic got routed, either based on client, geolocation, or some other business rule and attribute. So East and West took all of the different traffic, and Central really was overflow. So if the traffic manager couldn't determine where traffic was coming from, it all got routed to Central. So all the clusters were active, 2 were heavily loaded, and 1 was lightly loaded for additional traffic, upgrading, outages, and that you can take advantage. They were taking advantage of the Azure data center footprint, different data centers, right? Keeping microservices in sync and routing traffic. So you probably heard a little bit about the virtual kubelet project, and what that is about is tying ACI and AKS together. So ACI is just, I'm a developer and I want a container. So spin up a container. Spins up a container, you can run a job in it, fungible, then it goes away. You only pay for when the container is actually running. AKS, long-running jobs, microservices. So when you want to burst, now you have the option of being able to burst into ACI. So virtual kubelet represents a virtual Kubernetes node, and that allows you to scale using ACI instances, and those are stored in pods. So really bringing the best of the both worlds together. AKS, scaling up long-running microservices, and ACI, where I just want to spin up a container. Computer position, things like HPC workloads. AI and machine learning can take advantage of this as well. And last but not least, geo-replicated container registry, where now that you have different clusters in different regions, you can co-locate your container registry next to your compute. And one thing that we announced with ACR, you can not only co-locate your containers, you can co-locate the Helm repository as well. So the Helm repository where you're storing your configuration, your chart for deploying your apps, or now can reside in the same repository that your images reside in. So you're moving all your source and containers close to your AKS clusters, for instance. Okay, so that was basic AKS overview. Services associated, enterprise containers as a service. Now let's drill into some of the scenarios, the workloads, if you will, that people run on AKS and Kubernetes. All right? Wouldn't be a conference in containers without the old lift and shift moniker, right? I have existing monolithic, heritage, or legacy applications, right? All three of those are accepted to say your application old and static, if you will. Now I know if your enterprise, like, well, it's old and static, but it processes $1 trillion every year. Sure. The architecture is old and static, trust it. It's not a microservice, componentized based architecture. In that, you want to just take the applications and move them as is with as minimal change as possible to take advantage of containers, deployment, speed, agility. The microservice is where you're running discrete components. Your application is now componentized, you're running discrete components, your application is broken up into 20 different microservices that represent your app, all independently scaled, managed, and updated by different teams, right? Machine learning, AI, ML, running those models across Kubernetes and containers. And last but not least, one of the hottest spaces going, IoT workloads. IoT, getting IoT to the edge and different devices that are running on containers. So let's talk about lift and shift, or app modernization without actually touching the application. Modernizing it using containers and gaining some of the deployment agility that containers offers without doing a lot of code changes. So here from experience, there is a general perception that if you're moving from something like .NET Foundation to .NET Core, that's a long, arduous process. There's a bunch of tools that you can run against your source code, and the reality is 99% of the code will move quickly. So if somebody wanted to move from .NET Foundation to .NET Core, they can, without a lot of different code changes, right? And if you do that, then you're open to different types, particularly on the Windows side or Linux side, you're open to different platforms. .NET Core runs on Linux, it runs on Windows, it gets you to Nano Server versus Server Core, it gets you to smaller container images as well, okay? So key here is that you want to take the application as it is and move it over into Kubernetes. Now I know it says here, you want to use cloud database, and a customer reminded me, hey, if I have to change the database string from an instance of SQL Server over to something like SQL Azure, that represents a code change. It does, but it's a code change for good, if you will, right? If you move database instances over, immediately you have to start thinking about persistent storage and read many, write many storage for that SQL instance, right? Now you need to have persistent. Now you need to deploy persistent volume claims and persistent volumes in Kubernetes. It makes it a little bit more challenging, pushes it away from the stateless architecture. You can do it, not necessarily a best practice. Some things you have to actually decide about what storage architecture and things you want to actually use, okay? Microservices, this is the holy grail. This is it, right? We're all trying to get to a microservice architecture. And why is this so important to get to? It breaks apart your application into discrete components and functions as part of your application. And there's nothing like the realization that you're taking a monolithic application with maybe 3 services, building it or componentizing it, and now you end up with 50 microservices. It really should bring into focus the reason why you need container orchestration. Because each one of those microservices can be scaled, replicas, multiple replicas. They need to be load balanced, they need to be versioned, and they need to be deployed. That really kind of brings home the need for container orchestration. I had a number of enterprises I work with said, hey, I only have 10 microservices, what's the big deal? I said, okay, how are you going to scale each one of those things, trigger-based, in a declarative way? And they try with tools like Swarm initially. Generally, it takes a month before they come back and say, we need an orchestrator. This is challenging to manage, right? So really, if you look at the diagram, main monolithic app, everything like tightly coupled together. Microservices, loosely coupled, deployed and scaled independently. So sweet spot for the Kubernetes architecture where everything is load balanced, scaled, replicated, and scaled up independently based on some trigger that you actually have in the environment. Okay? Now, I talked a lot about some of the basis of the architecture, talked about lift and shift, microservices. You're probably tired of hearing from me, so why don't we hear from my friend Rasmus from Maersk, who's the head of cloud architecture, talk a little bit about how they've used AKS with their microservices architecture in a real customer scenario. Okay?
Excellent.
Thanks.
Thank you.
Yeah.
Thank you. And that was definitely for you. Absolutely. Okay. Hey, thank you for allowing me to be here on stage, and I'm super proud to be able to come here before you and share a bit of learnings from our cloud journey and our journey together with Azure and AKS. So I have a bit of examples to share with you today, but first, just want to make sure that you know who Maersk is and what we represent. So any of you know who Maersk is? I'm going to put the star up here, so maybe you recognize that one. So we like to say that we are the global integrator of container logistics. And you can imagine if you are a market leader in the container space, we are also the leaders of container punt jokes, and I can imagine that you would enjoy some of them. So we run 3.5 million containers, but they're all made out of steel, and they don't auto-deploy or auto-heal or anything like that. That is a very physical business. I would say about 350,000 of them, they have an IP address, and they are IoT enabled. So we are getting into the tech space. But I won't discuss any of that today. Today I will touch upon how we use AKS services. So being the global leader in this space, we are a very physical business. We call it an asset business. We move about 20% of global trade based on ocean. And that takes ships, and ships are also made out of steel, and are also very disconnected from the cloud. And that brings in some very interesting scenarios for us. So I'm here to share a bit about what we do in my team. We build cloud natively. We like to say we build with native cloud building blocks. And AKS is one of the key elements that we're using in our journey. So the solution that I'm bringing before you today is based on a key pain in the industry. Now, that is the pain of customer satisfaction. Now, many of our relationships are business to business. So we deal with producers, manufacturers, factories, and retailers, and we move their stuff. As you probably know, much of what is being produced in this world comes from Asia, and most of it is being consumed in the US and in Europe. And we sit key in that. However, our industry suffers from problems with NSAT or customer satisfaction, as we see an increase in digital services in the consumer space. Just think of yourself when you're tracking a package, a delivery, via one of your local carriers. You're used to always knowing where your goods are. Now, this sets expectations to our industry as well, as part of this increasing digital industry. So we need to address that. Also, we are a very traditional business. We have a lot of history. I'm sure you also are some of you are in businesses with a lot of history. And our information is very siloed. Our processes are very siloed based on different business units. So the solution that we're going to discuss today is from a business standpoint to address, this industry challenge of customer satisfaction. However, it is actually a data-driven app. We have thousands of my colleagues facing customers every day, providing good customer service. However, their customer service are always based on data, like a container booking, for example. And just surfacing great data for them has been a challenge for us, and the solution that I'm presenting today addresses that. So we have a journey for this application. First, we need to digitalize a very manual process. You can imagine customer services representatives taking data from one system, searching in another system, inputting in a third system. Now, taking all that process and digitalizing that is super important, and that will give us much better customer service. But that also introduces the potential to go in and build even better data-driven apps in the future, and collecting data so we can build machine learning models. So we see a long path of very valuable initiatives we can build here. So let's build it in the cloud, of course. We have a very clear cloud strategy. Our cloud strategy is to put in cloud first. In this case, it's a greenfield deployment, so we can architect to the standards of today. However, some of the challenges we've seen is that this application is memory and compute intensive. We have a principle called pass over containers over traditional servers. However, sometimes we need a higher flexibility than PaaS services can provide, like the Azure App Service. And that's where we need more flexibility in the solution. We also have challenges with getting the data from our on-premises systems, and limited experience in working with Kubernetes, especially considering that this is one out of multiple initiatives using Kubernetes as a platform. As requirements going into this, we have some strong architecture principles. We build in isolation in the cloud. So cloud native for us means that we don't put things on the corporate network. We build islands in the cloud. Again, we build with cloud native building blocks. And we insist on automation. One of our principles is, in fact, that no human person should have access to production environment. We do everything via pipelines. So let's get into our architecture here. Our architecture is based on, again, these principles. And surrounding these Azure Kubernetes services are a number of different Azure services. The first one I would like to mention is Azure Pipelines, or the previous called VSTS. We use that to implement the requirement for heavy automation. So we allow our developers, our engineers, full access to any development environment. We call it lower level environments. So they can go and mess it up in their own time, and we can redeploy at any time. However, when you're getting ready for production, any engineer will not have access to the real environment. They can go and view it in the Azure portal. They can pull statistics out of it, but we do not allow you to tamper with the production environment. And pipelines helps us implement that. Key Vault is also part of this solution, and we use it primarily for two things. First, managing our secrets. And as Alan mentioned, this is actually one of the bigger challenges in Kubernetes. So just having a vault there that you can reference solves part of the problem with managing your secrets. Another thing we'll use it for is our persistent configuration store. So just imagine your connection strings, rather than putting that in the container, well, referencing that stored in a key vault is really powerful for us and helps us keep our containers immutable as is. Azure Monitor, or container monitoring, is also key here. And a lot have happened, especially this week, in this field. So Kubernetes itself introduces a different security context on its own, right? You have a kube admin account that you can sign in with. And you use that to go and check out the log files when you're debugging. But abstracting those log files into Azure means that we don't have to allow the engineers, or we don't have to force the engineers to sign into Kubernetes to do their debugging as they're developing the solution. Quite powerful. And the RBAC model that we get by using Azure Active Directory as our security context for Kubernetes is also helping simplify the setup and just getting the engineer ready to code as soon as possible. For data integration, we will, at least for the interim, do transfers of data from our systems of record that are hosted on premises, and use components like the Azure Data Factory and Azure Data Management Gateway to get our data out of our legacy systems. Put that data up there in the cloud so we can work with it and inject it back into our systems of record. Now, there's a lot of details to this infrastructure, of course, but these were some of the key highlights here that really helped us enforce our architecture principles and give the developers, our software engineers, the speed and agility they need to go and develop this solution as quick as possible. So the key takeaways, or the key results out of this has been environment provisioning. Now, some of the stats standalone here might not look super impressive, but we come from a traditional ITIL world, or IT service management world, where it could take potentially up to 6 months to get your production environment ready. Now, we can quickly bring that down to weeks when we're developing a Kubernetes-based solution. But today, we can do this from scratch in 2.5 hours, and that's actually 2.5 hours where you can have coffee and go and do other things. So just having this fully automated end-to-end is truly powerful. Deployment times and developer autonomy has been increased with the introduction of Terraform. We do not dictate the language use to configure and work with AKS, and developers seems very happy with Terraform. And introducing that really speeds up our deployments, but it also empowers developers to tweak their environments much more smoothly. And one of the other key things here is keeping secrets. Just keeping your secrets unknown to humans is powerful, right? It removes the entire problem of rotating keys, of managing keys, and just getting that problem out of the way. So the last thing I want to mention is the impact on production cost, on run cost. Now, today we're saving around 33% of time, so that's people's time that we can use on something else. And that is actually powerful because we get Kubernetes in a state where it's ready to run. We don't have to build that knowledge ourselves. So with that, I would like to hand it back to Gabe. That will take you to further. Thank you.
Thanks, Rasmus. That's really great to see. It's awesome to be working with a partner like Maersk who's so thoughtful about how they're using technologies like this to handle really mission critical workloads. It's very, very impressive to see what the results look like. So we've talked a little bit about app modernization, this idea that you can use containers in Kubernetes to take old workloads, wrap them up in a container, shoot them up in the cloud, and really provide some new life to those workloads through things like CI/CD, and allowing better reliability through things like self-healing Kubernetes clusters. We talked and heard from Rasmus about microservices and how microservices can really accelerate software development inside your organization. But there are a couple other use cases I want to talk about as well, and these are sort of new and up and coming. The next one I want to mention is data science and really machine learning on Kubernetes. There's a huge amount of a big sort of movement around getting data science into a place where it can be it can leverage portable technologies like Kubernetes and containers. This is manifest in projects like the Kubeflow project and different efforts sort of in the Kubernetes ecosystem. Now, for those of you who are not familiar with machine learning, it basically breaks down into two fundamental primitives. One is the idea that you do model training. right? And so model training is where you're a data scientist, you're gonna produce some algorithm that you think is gonna train a model. You will use some training data to train that model. And running that training and producing a model is, containers and Kubernetes are actually perfect for this, right? It's typically very CPU-bound workloads. You can load that data into Azure Files or Azure Blob Storage or some other place where you can sort of store the training data, burn through it with just pods running on VMs, or even something like ACI, potentially even managed by Kubernetes using our virtual node effort. And then at the end of that, you're going to get a trained model. And that trained model could do something like, sentiment analysis. Like you give it a picture and it can determine whether someone's happy or sad and sort of score their sentiment on a score of 0 to 100, right? And that is typically deployed as a web service, right? Or standard REST API service. Now, the important thing to point out is you can actually run both of these parts on top of Kubernetes and on top of AKS, and we have a lot of people doing that today. You'll use maybe GPU-backed machines to do some of the model training, where you really need the GPUs and the raw compute to produce the model. And then you'll use maybe standard VMs or standard web serving techniques with containers to actually run your model serving. So this is a very common pattern that we see in the industry today. And if you're exploring data science, or if you're looking at applying deep learning into your portfolio of what you're doing, definitely check out what we can do in terms of AKS. I do want to point out that there's lots of other offerings inside of Azure that make machine learning easy, right? But again, going back to this point about Kubernetes and why it's valuable, if you need to make sure that what you're building can run on any environment, right? Whether maybe you need to be doing your inference on a ship that's floating in the middle of the Atlantic Ocean, right? If that sort of portability of and environment compatibility is important to you, you may want to be looking at platting your data science platform on top of something like AKS. So I want to talk a little bit about a customer called OpenAI. Who here is familiar with OpenAI? They've recently been doing this Dota 2 challenge that has been in the news. Anyone familiar? Hands? Okay, so OpenAI is a very interesting nonprofit. So what they were done is, this is Sam Altman and Elon Musk actually founded a company to try and really democratize OpenAI and make sure that the results could be shared and built in the open. And what they've been doing is, they're really just on the cutting edge of a sort of deep learning technology. One of the things that they're using to demonstrate the how sophisticated their AI is by playing extremely complicated games. Now, these are actually multiplayer games now, and so what they do is they will train these models on using video games, using a project that's called the Universe, and they'll train sort of the model and make sure that it learns how to play video games from scratch. In the beginning, the character dies every time, and then slowly over thousands and thousands and thousands of plays, it learns how to become an expert. And they're now entering into esports competitions, battling against some of the best teams on the planet. And all of this technology that they're using on the deep learning side is powered by containers and Kubernetes under the hood. So obviously, the containers and Kubernetes aren't why they're successful. They're successful because their data scientists and their algorithms are terrific, and they're pushing the boundaries there. But without the infrastructure component, they wouldn't get very far. So it's important to know that a lot of this stuff has historically run and still today runs on Azure. The next thing I want to talk about is IoT. We are just seeing an explosion of interest in IoT and this idea of sort of sensor data everywhere. And there is a lot of benefits to using Kubernetes and container technology to tackle this problem. Again, it's portable code that can run anywhere. You get elastic scalability. Lots of interesting elements to why this might matter. So typical architecture for this might look like an AKS cluster with some backing stores, a component that we have called the IoT Edge connector, which basically provides a bridge between AKS and the Azure IoT product suite, specifically Azure IoT Hub. Now, this allows you to manage devices at global scale. And this is extremely important, and we're going to see a demo of some of this technology in a minute here. Now, the thing I want to point out, and part of the reason why it's Kubernetes is important here, is this consistent management between the cloud and the edge. So what will generally happen is IoT Edge is going to encrypt data, send that data off to Azure, which will then sort of decrypt it and send it off to some storage backend, right? You have to store this, typically sensor data, things like that somewhere, right? Then what we have is we have these virtual nodes, based on this virtual kubelet project that we talked about, which serves as a translator between the cloud and the edge component. Think of it this way: there's logic that needs to run for each of these IoT devices, right? So every time the sensor does something or something flips from green to red, we need logic to handle that event. And so what you can get to is you can get to this world where you actually have a Kubernetes pod that's mapped to a single device. And that actually turns out is a really good way to model some of these environments. And again, you're going to see that here in a minute. Now, we also have this, because the IoT Edge provider uses the virtual kubelet, what it can do is it can actually manage shooting these workloads off to some device on the edge, and basically allow the developers to use Kubernetes primitives to program IoT-based devices. So the theory here goes, well, your developers are already writing containers, they're already building containers, they already know how to use the Kubernetes API. Wouldn't it be great if we could just take those Kubernetes APIs and allow them to be used to actually manage devices at massive scale across a really broad IoT deployment? So to show you some of this, I'd like to invite up Janny here, who is not only an Azure MVP, he's also the Microsoft Regional Director, and really an expert in the world of IoT and Kubernetes.
Thanks, Gabe. Incredibly excited to be a part of this presentation. So, we talk about web scale when it comes to Kubernetes. So we scale from a handful of containers to tens of thousands of containers in just a few minutes. But on the other side, there is a huge explosion of devices. So when you consider scenarios like smart cities, smart buildings, smart grid, smart healthcare, there are millions and millions of devices that are getting connected to the cloud. So does it make sense to bring the concept of Kubernetes control plane to manage the explosion of these devices and manage them at scale? So that's exactly how we are bringing Kubernetes closer to the edge and trying to bring two different scheduling engines together to manage deployment of edge modules at scale. So the scenario that I have here is basically reflecting a smart building. So visualize a smart building where every floor of that building has an edge device, and that edge device is responsible for controlling some HVACs, some lighting, and a variety of devices. Now, if I'm a Kubernetes administrator, I would love to push firmware updates or modules that basically control some of the devices connected to these edge gateways. And I want to do it at scale, not only just at scale, but I want to use Kubernetes primitives like blue-green deployments, rolling upgrades, rollbacks, and basically use PaaS-like operations to manage my edge devices deployed in these smart buildings, and use my familiar kubectl CLI to do all of this. So what I have here is essentially, give me a second while I refresh my Azure portal. So I have two different control planes. The one that you're going to see here is going to be the IoT Hub, which is the standard Azure IoT Hub that's already configured. And this is essentially connected to an edge gateway. So I have a Raspberry Pi device here. This is acting as the edge gateway. So nothing special. This is just yet another device flagged off as an edge. Now, what you see here, the lower part of the window, the terminal, is basically the edge runtime. This is the Azure IoT Edge runtime. And every module that runs on this runtime is essentially going to be a container, which is called as a module. So the runtime has some default containers deployed as modules. The edge agent maintains the connection to the IoT Hub, which is responsible for managing the deployments to every floor of the building. Then we have the edge hub, which provides local connectivity. Now, I also have a smart bulb that is actually going to be controlled from our edge device. So what I'm going to do now is to use my favorite kubectl to basically deploy. But before that, let me show you what I'm running. So I already have the Minikube up and running on my machine. So you see Minikube as one of the nodes, very obvious. But what's interesting is building one. So building one, which is showing up as a node, is actually not a node. It is an IoT hub, which is connected to one of the smart buildings that we are trying to manage. And the connection between Minikube and the IoT hub is bridged via virtual node, which Gabe has been talking about. So with that, I basically get access to the IoT hub from Kubernetes. It's a phenomenal technology to bring two different scalable worlds together. Kubernetes on one side and device management at another end. So let's go ahead and deploy my module, which is going to turn on the bulb. But before that, let me show you how this looks like. This is a standard pod definition. Again, if you are familiar with Kubernetes, you notice that this is just a deployment. It has an image, which is called bulb v1. And it also has some annotations. For example, we are targeting all the devices that match type bulb. It also has a config map with some configuration in place. I want to run this on the host network. I want to run the container in privileged mode. So I pass all that. So anyone who is familiar with Kubernetes can instantly relate to this because it's a standard YAML definition. So what I'm going to do now is take this YAML and run it against my Minikube. So when I actually do this, my bulb module is first deployed on Minikube, and Minikube tries to understand what is happening. And the annotation clearly tells, don't do anything, pass it on to virtual node. And virtual node is nothing but an IoT hub. And that IoT hub is going to take over scheduling and pushes that onto one of the edge devices, which will eventually light up the bulb. So here we're actually seeing the edge hub and edge agent up and running. In just a few seconds, we'll see another module getting pushed. And it's going to take about a minute or so. And as soon as that bulb module comes up, we'll notice that the smart bulb that we have here lighting up in blue. So while this is going on, I want to switch over to the portal and show you what's going on there. So this is a standard IoT edge interface on Azure portal. And here we have the device twin. And again, if you're not too familiar with Azure IoT terminology, don't worry. Device edge is like a digital replica of the device. Here I have my IoT edge. And within that, I have Pi1, which is my gateway, actually. And here, when we look at the device twin, we'll notice that I put some annotations, which is saying device ID is Pi1, and type is bulb. And guess what? I'm actually using the same thing in my YAML definition. So tags.type is bulb, which is basically an indication to my Minikube and virtual node to control. So OK, now the edge hub has failed, which means there is a refresh happening. So I'm going to hold this. And very soon, we'll actually notice that the bulb module shows up in the list, and this turns blue. I also have a Raspberry Pi device here. I'm basically running an intranet of things. Not exactly. There we go. So the bulb glows up blue. That's not all. Remember, we got to do blue-green deployment. So now, what I'm going to do is come back to my kubectl and then upgrade my image from V1 to V2. So I'm actually taking the Kubernetes route to upgrade my module from V1 to V2. And now, very soon, in about a minute, we'll notice that the current version of bulb, which is V1, it'll get knocked off. And Azure IoT Edge will push V2. And right after that, we'll actually notice that this bulb becomes green. And if you have a massive deployment, you can actually do a blue-green deployment there. So there we go. Now let me hold this. And in just about 30 to 40 seconds, we'll notice V2 getting deployed onto the edge, and this bulb becomes green. So let's give it some time. And meanwhile, I'll also show you what is going on here. So essentially, when I do this from Kubernetes, you'll notice that this is the deployment that is showing up. So currently, we targeted one device, and it got applied. Very soon, we'll notice another deployment coming up. There we go. It's now targeted and applied, and now the bulb turns green. Right? So that's not all. Remember, you are actually using Kubernetes. So how about this? Can I do a rollout history and look at what I did with my deployment? This is almost like pass-based operations. So it's not just pushing a module. Now we have 3 different steps recorded as a part of our rollout. If I want to do an undo, right? For example, I'm not happy with this latest version of the firmware, so I want to do a rollback. So now I can actually undo, and that takes my image back from currently from V2 to V1. And in that case, we'll actually see this bulb becoming blue again. And all this from kubectl without any understanding of IoT edge. And that's the beauty of AKS and the virtual node, which is going to bring in 2 different worlds together. And now we are rolling back. The bulb is switched off. And very soon, we'll go back to V1, in which case we are back to blue. So I visually chose the colors of blue and green because I want to demonstrate blue-green deployments, albeit with just 1 device. But you get an idea on how you actually achieve this at scale when you have like a massive smart building or a smart city-like scenario. Let's give it another few seconds, and we should. There we go. So now we did a rollback, and we are back to V1, which is blue. By the way, that magic is orchestrated by a Raspberry Pi, which is running the IoT Edge gateway on this. So this is running backstage in terms of an intranet of things. Though it looks very simple, there's a complicated setup behind the scenes that is orchestrating the whole thing. But the front end for this is kubectl, targeting Minikube or AKS, virtual node, and then Azure IoT Hub. So that's all. Thank you.
Thank you, Jay. Wow, how awesome is that? Another round of applause for Janie, folks. That was too cool. I love how he was able to not only just show the IoT use case, but also, for some of you who are new to Kubernetes in the audience, just show how kubectl works, what the YAML files look like, what rollouts and roll forwards look like. So hopefully that was extremely useful. Great, and we also got a bulb that's still blue up here, so that's terrific. So a couple things I wanted to mention here. We talked a little bit about the virtual nodes project. So in case you haven't seen, you weren't able to see the demo that Corey did during his keynote, what this allows you to do is this pairing of AKS plus ACI is it allows you to provide auto scaling at a level that we've not yet seen in the industry. So specifically, we're able to mitigate a load event from like a Black Friday, scenario where like you just have a bunch of people hitting a website all at once and it was unplanned. We can actually now, thanks to the magic of AKS virtual nodes, we can actually mitigate that load event in around 20 seconds. Which is pretty miraculous, and really there's nothing else out there in terms of VM-based operations and VM-based auto-scaling that can even come close to that time. So we're really excited to see this going. If you want to get involved in the preview, please sign up. I know the team's been rapidly onboarding people into the preview today. So. Yeah, please go ahead and sign up. A few other announcements I do want to call out. One thing that I get asked about quite a bit is our story around on-premise. And so we do actually have Kubernetes on Azure Stack is now available in public preview. This uses it's still an unmanaged Kubernetes in the sense that we don't offer the management of sort of the master components, but we do offer a sort of Azure blessed version of Kubernetes that you can run on Azure Stack. So some of the stuff that Janie was doing, for example, can be done on-prem. Now, the last thing I want to talk about just real quick before we go to Q&A here is around open source culture. One of the things I just wanted to talk about before I get into this slide, this product group that I work with is not like a lot of the other product groups inside Microsoft. We're actually involved in taking software that's being built by a community of individuals in an open source model, including some of which are competitors and folks like that. And we're taking that software, making it run great on Azure, and then building terrific products and services off of that. Now, in order for us to be successful in that endeavor, we have to make sure that we are able to give back, right? We can't just take, we actually have to give back. So in addition to making this possible to work with different open source tools and APIs, which is one of the big benefits of interacting with sort of the open source ecosystem, it's also important that we are giving back. So we actually work with lots of different companies here on helping shape what they're doing inside open source, and again, helping make sure that stuff runs on Azure so that you all can get really great experience with this entire set of products. We also do a lot of contribution, right? Like, if you didn't know this, the co-creator of Kubernetes, Brendan Burns, my counterpart on the Cloud Native Compute team on the engineering side, he is the #2 contributor to Kubernetes, which isn't surprising given that he created it with a few other folks. But we also employ the #4 contributor to Docker, the #1 through 3 contributors to Helm. 70 employees have made contributions to Kubernetes from Microsoft, and that doesn't count the rest of the products sort of and projects in and around the Cloud Native Compute ecosystem. I myself sit on the board of the Cloud Native Computing Foundation, which is the Linux Foundation group that kind of manages and looks after Kubernetes and associated products. So we are actively trying to give back. We realize it is important to give back and not just take. And so you'll see that reflected in lots of different ways. The most important one is better products and a better Azure experience. Last thing I want to point out is just some resources. Lots and lots of container sessions at Ignite. Endless. So if you want to snap a pic, definitely do that. Wonderful set of speakers. It's just been a pleasure for me to see how fast container technology has taken off inside of Azure and how many experts we have available to come talk about this stuff, as well as customers. And lastly, we have some resources here, to some links. I would definitely recommend checking out the Smart Hotel 360 application. If you want to get a sense of what a real-life microservice application looks like, that's a real good example, and it actually deploys onto AKS quite easily. Lastly, your feedback is extremely important to us. It's important because we all want to know how we can improve as speakers, but also we want to make sure that we are giving you the right content and making these sessions and events like Ignite better and better every year. So please do take a moment and fill out that feedback and let us know what you think. That is it. Thanks, everyone.